So I hope everyone read the Blackboard announcement. I moved the quiz up a bit in the hope that you'll have more time to study between quiz 3 and test 3. Ideally, I give it and then the test is right after it, but you guys never seem to have time to come pick up the quiz, so I think if I have the quiz a little bit earlier, there's a better chance I can get the quiz back to you before the test, and maybe that'll help. That's my hope. And so anyway, I've also opened all the homework from, start of the course pretty much up till test 2, and then, of course, the homework, which is to prepare for test 3, is due before test 3 because, the time to do homework to prepare for test 3 is before the fact, not after it, right? Okay, so we have reached section 5.5, which is on solving rational equations. And so what we're going to do here is make use of the algebra that we have thus far learned. So we'll start out relatively simple. Example 1, something like x over 3 minus x over 4 equals to 12. I mean, honestly, this problem here, we could have seen earlier in the course. Example 2, I'll do 3 over y plus 1 is 2 over y minus 3. Let's see here. Example 3 will solve x plus 1 over x equals to 3 halves. Let's see here. Example 4, we will solve 50 over y minus 50 over y minus 2 equals to 4 over y. I'm going to change those to x's so you can tell the better difference between my letters and my numbers. Let's see here, 4 over x. So I'll start with those. We'll see where that takes us. So what do you guys think about example 1? What should we do? Find the common denominator of 3 and 4? Yeah. What would that be? 12, right? So we certainly could do that, right? And so we get what? 4x over 12 minus, 3x over 12, which is giving us x over 12 equals to 12, right? So then multiply both sides by 12, what do you get? 144, I heard. Very good. Now, that's a perfectly good way to solve this problem. Can anybody tell me another way we could have solved this problem? See, one of the main differences between what we were doing and what we're currently doing is before we were working with expressions, right? So you can't just take an expression and multiply it by 12 because that will change the expression, right? But you can take an equation and multiply it by 12 because that does not change the equation, right? Multiplying an equation by 12 is not going to change the solution set, so it's the same equation. So one of the things I could do here is just multiply by 12. So like 12 times x over 3 minus x over 4 is equal to 12 times 12, right? And what would that give you? Yeah, so this 12 over 3 cancels to give me 4x, and then I get 12 over 3 minus 3x equals to 144. X is equal to 144. So, I mean, that's another way you could do this problem. Okay? And I think that's not a bad move to make when you've got fractions. If you can multiply by a number that changes all the fractions to whole numbers, then that's a win, right? Because arithmetic with fractions is trouble, right? How about this one, example 2? What do you guys think? Here's what I would do. I would multiply this equation. I would do what's called cross multiply, right? I would do say, okay, well, this is 3 times y minus 3 equals to 2 times y plus 1. So what I've done to get from here to here, what did I do? I multiplied by y plus 1 times y minus 3. See, if I multiply the equation by that, what happens is the y plus 1 cancels on the left-hand side, right? And the y minus 3 cancels on the right-hand side. Okay, but this is often referred to as cross multiplication, so just, something to remember, algebra. Let's call it an algebra move. If you have a over b equals to c over d, you can trade that for AD equals to BC. This is called cross multiplying. Multiply the denominator of the left to the numerator of the right, and multiply the denominator of the right to the numerator of the left. And of course, once you get to that, we're kind of like back to the kind of equations we solved week 1, right? What do you got? You got 3y distribute minus 9, right, is 2y plus 2. Isolate your y's. So you've got, 3y minus 2y is equal to, 2 plus 9, right? Which gives us y equals to 11, right? What's a good idea to any algebra problem like this? Once you get like maybe 3 steps or something, that's it's worth your time to check your work, right? Can we check our work? Let's check our answer. How do we do that? So we need to check, is 3 over 11 plus 1, is that equal to question mark 2 over 11 minus 3? So what do we got here? We got 3 over 12, right? Is 3 over 12 equal to 2 over 8? Sure is, right? Those are both a quarter. So that shows us that 11 is in fact a solution, right? The algebra steps we did lead us to a correct result. Do you have to check your answer? I mean, you don't have to unless I say check your answer, right? But it's an easy way to keep yourself from losing points on a test, Anyway, how about the next one? What do you guys think? I guess we could cross multiply again, right? So what do we get? We get 2 times x plus 1, right, is equal to 3 times x. So I cross multiplied. So then what do I do? Solve for x, right? So we got what? We got 2x plus 2 equals to 3x, which gives me 2 is equal to 3x minus 2x, right? In other words, 2 is equal to x. And you can easily check your answer again, right? If you plug 2 back into the original equation, you get what? 2 plus 1 is 3. 3 divided by 2 is 3 divided by 2. Okay, so it works. I mean, if you plug it back in, plug 2 back into this, you can easily see you get 3 halves equals 3 halves, right? So that's good. Ooh, how about this one? What do you guys think about this one? This one's more troublesome, isn't it? We can't just cross multiply this thing, can we? However, if we could make the left-hand side into a single fraction, then we could cross multiply, right? How can we make that into a single fraction? Do what? Like we did before, right? So we do 50 times x minus 2 over x times x minus 2, right? Minus 50 times x over x times x minus 2, right? Equals to 4 over x, which gives me, what does it give me? It gives me 50x minus 100 minus 50x all divided by x times x minus 2 equals to 4 over x. So what I did was I distributed, sorry guys. Come on. I'll answer it, why not? There we go. So they've been trying to reach me concerning my car's extended warranty. What do you know? The funny thing is I never bought a warranty on my car. So I don't know, it's quite a mystery. Someone must have bought it for me. So I think that's gone on long enough. Usually they hang out after you don't talk to them. Anyway. So what I did was I multiplied 50x times, I got 50x, and 50 times 2 is 100, but I got a minus, so minus 100. And then this is the minus 50x. You notice what happened here? Your 50x's canceled, didn't they? Yeah? So I'll write one more step before I cross multiply just to clean it up a bit. So I've got minus 100 over x times x minus 2 is equal to 4 over x, right? So your goal with these fraction problems, there's different ways to go about it, all right? I can show you a very different way to solve this problem after we're done with this if you'd like, but if you can get it to a fraction equal to a fraction, then you can cross multiply to solve it, right? So that seems like a reasonable strategy here. So we cross multiply, we get what? We get minus 100x is equal to 4x times x minus 2. We're still not done. And look at this. We're not left with one equation and, like a linear equation like we've been in the past examples. This is a quadratic equation. But the good news is we can solve quadratic equations, right? So this gives me 4x squared. I'm writing the left-hand side as the right-hand side, so I get, well, fine, I'll keep it like it is. Minus 100x equals to 4x squared minus 8x. Then let me rearrange this. We got 4x squared plus 92x equals to 0, right? Does 4 divide 92? Well, 4 times 25 is 100, right? So 4 times 23 is 92. So this is 4 times 92 is 4 times 23. So I can factor a 4 out, right? I've got 4 times x squared plus 23x, yeah? Which then we can factor, right? Well, half of you can factor, half of you cannot, from what I saw in test 2. Factoring is a necessary thing for passing this class, Like, it's hard to pass this class if you can't factor. That's just true. It is foundational to, like, most of the questions I ask on the final, like a good bit of them, because factoring figures into, like, the middle part of the course, but it also figures into this stuff, right? Because it just keeps cropping up. Like, factoring is something we need to know how to do. So if you don't know, you need to, seek a tutoring or something. Try to fix that. Just saying. Friendly reminder. So I can factor x out. I get x times x plus 23 equal to 0. So what are my solutions? x equals to 0 or x equals to minus 23, right? And then put a box around them, and we're done, right? Hooray. Except something is not right. You guys tell me, which one of those solutions must I reject? Because if we go back to our original problem, it doesn't check. I heard 0. Very good, because 0 is not in the solution set. Notice that 0 is no allowed. Final added T, grammar people. 0 is not allowed there. Division by 0, right? So this 0 is what's called an extraneous solution. It's not even in the solution set, you know? How did it get there? How do we end up putting that in the solution set? The way I think of it is this. When you make the step of cross-multiplying, that step really going from here to here, this fails for x equals to 0 and x equals to 2, you know? So what that means is, in going from the top step to the bottom step, you're changing the nature of the solution set in the sense that you might add or lose 0 or 2. In this case, we end up adding 0 to the solution set. Because 0 is, in fact, a solution of this last equation. That's true. It's just that this equation is not equivalent to that one because we changed the solution set by cross-multiplying. This is kind of a subtle point, but this is why when we make a cross-multiplication step, it's important to check your answer, to not be deceived in like giving an extra answer that's not really an answer. Okay, but I just want to encourage you that it's not that mysterious. The reason it happened is because this algebra step is not allowed in the case x equals to 0 or x equals to 2, right? We just do it and hope that we find something interesting and then check our answer. That's our method. Any questions? Let's see here. Let's look at another. So I'm going to, example 5. Here we have x squared plus, x cubed plus 3x squared plus 2x divided by x squared plus, I don't know, 10x plus 25 equal to 0. How should we deal with such a problem? What do you guys think? My question to you is, how can a fraction be equal to 0? Right? Like, how does that happen? Does it happen from b being 0? No, I mean, if b is equal to 0, it's just undefined, right? So the only way that this can have a solution is if the numerator is 0, right? So answer need a equals to 0. So in this, that's like a general idea. For this problem, we can say, okay, so we need x cubed plus 3x squared plus 2x equal to 0, right? How would you solve that? I'll do the easy part. I'm going to factor an x out. Are we done? Can you factor x squared plus 3x plus 2? Here, I'll get us started. You guys think about that. Figure it out. So we got plus 1, plus 2? All right, good. So then what? Well, that's equal to 0. How can this be equal to 0? What's that tell us? It tells us either x is equal to 0, x is equal to minus 1, or x is equal to minus 2, right? And what is that numerator, by the way? So this guy right here is actually what? It's actually x plus 5 squared, yeah? So the only way the denominator can be 0 is if x is equal to minus 5, right? But the places we found the numerator to be 0, none of them are minus 5, right? So we can plug 0, we can plug minus 1, we can plug minus 2. Those all could be plugged back up in here, and they give you solutions. They don't make the original equation undefined. Those are all solutions. None of them are extraneous. Okay. The only number which makes this fraction undefined is minus 5. All right. So comment. If we had f of x equal to x cubed plus 3x squared plus 2x divided by that, which is x plus 5 squared, what's the domain? Minus infinity to minus 5, union with minus 5 to infinity, right? We just have to exclude minus 5. We talked about that at the start of this whole discussion about rational expressions, right? Talked about the domain. Just circling back to that for a second. All right, let's look at another one. Unless there's a question. You guys can ask a question if you got one. That's always the case. Let's see here. How about, this one looks a little different. Here. We've got 7 over x minus 2 minus 8 over x plus 5 equals to 1 over 2x squared plus 6x minus 20. This is example 6, I suppose. So when I see this problem, the first thing I want to do is figure out what is this 2x squared plus 6x minus 20. Can it be factored? Because if this actually happens to be these, then that makes the problem like a lot simpler. So let's just sidebar here. 2x squared plus 6x plus 20. I factor a 2 out, minus 20, right? Minus 20. So that's 2 times x squared plus 3x minus 10, right? Which is 2, that looks like x plus 5, x minus 2. Aha! So actually, we're faced with something that cross multiplication, like multiplying this equation. Let me rewrite the equation one more step here. So this is 7 over x minus 2 minus 8 over x plus 5, right? And that's equal to 1 over 2 times x plus 5 times x minus 2, right? That's what we're facing. So a simple way to solve this kind of problem is just to multiply by the common denominator. So if I multiply this equation, multiply the equation by the common denominator, I'll multiply by x plus 5 times x minus 2, and I'm just going to write it out. So we have x plus 5 times x minus 2 times 7 over x minus 2, right? Minus x plus 5 times x minus 2 times 8 over x plus 5 is equal to, again, so multiplying the whole thing by this quadratic. And so the reason I did that, of course, is that what happens is you can cancel out. How's it work? So this cancels that, right? The x minus 2 reduces with this x minus 2. This x plus 5 cancels that x plus 5. And we've got 7 times x plus 5 minus 8 times x minus 2 equals to 1/2. Let's see here. So that gives us 7x minus 8x, which is minus x, plus 35 plus 16 equals to 1/2. So let's see here. Minus x is equal to 1/2 minus 35. 35 plus 16 is what? 45, 51, right? Or in other words, x is equal to 51 minus 1/2, which is also known as 102 minus 1 over 2, which is 101 over 2. So there you go. 101 over 2 is the answer here. And you can go back and see that that actually does work for this equation, because x equals to 2 and x equals to minus 5. These are the values which are not in the domain of definition for the equation, right? 2 and minus 5 are the troublemakers for this original problem, yeah? And we found the solution's 101 over 2, So at the start of this lecture, I, sort of was trying to champion checking your answer. Checking your answer here is kind of a mixed bag. Like, this problem is complicated enough that checking your answer is almost as hard as solving the problem. Like plugging 101 over 2 into that, it is something you'd have to spend some time doing, right? So you got to make a decision whether or not you want to check this answer on a test, right? But there's usually a lot of time on your test, so you could do it. All right. I'm going to move on here. That's a pretty good selection of problems from section 5.5. I'm trying to remember if I have assigned 5.6 to you guys or not. Do you know? Right offhand. Anybody have their course planner in front of them? I'll find out here in a second. You don't like it. What don't you like? Oh, I thought you said you don't like it. See, this is the danger. You got to talk louder so I can hear it. Wait a minute. Why do you have a blanket? It's freezing outside. Are you serious?
Yeah.
It's cold? Yeah. Oh, okay. Hmm. It seemed pleasant. Yeah. I mean, my kid was in the pool yesterday. Let's see here.
Was it?
No. All right, I have spared us section 5.6. You can thank me when you look at it. All right.
Did you spare the word for all the word problem ones?
Oh, I seem to also have spared you section 5.7. I like 5.7 though. Well, anyway. Every so often, you may think the grass is greener on the other side of the fence, so to speak, like there's another section of 101, and you might think, oh, like Dr. Cook is like making us learn completing the square, but they don't really have to complete the square in the other section. I don't know. They may or not. But trust me, there are lots of things in sections 5.6 and 5.7 that the other sections cover that I do not. So whatever I add, I also take away something. So
Very much appreciated.
lest you think that I'm trying to give you too much value in your education, rest assured I have cheated you of some topics. So and you're appreciative. That's good. All right. So this brings us to 6.1. 6.1. And section 6.1, chapter 6, which is on radical expressions and square roots and all these sorts of things. And so let's see here. Oh. So here we go. So this is on radicals and exponents, all that jazz. Chapter 6. Okay, so symbol, square root, is called a radical. All right, good to know. An expression written with square root is a radical expression. So what we're going to be learning is how to simplify radical expressions and eventually how to solve equations involving radical expressions, right? Whatever goes in the square, the radical is called the radicand. So like if I had square root of x squared plus 7 as radicand x squared plus 7, for example. Okay? So some things I should tell you about square root, right? Because I don't know if we've talked about square root much in here before. Maybe early on we did a little bit, but So definition, if we say the square root of, let's say y equals to x, then that means that y is equal to x squared, right? And x is greater than or equal to 0. So this is what square root of x squared, the square root of something, for example, if I have the square root of 25, what is it equal to? Well, you guys know. Yeah, this is equal to, the square root of 5 squared, very true. So it is 5, right? Because why? Since 25 is equal to 5 squared, right? So that makes the square root of 25 5, right? What else squares to 25? Well, notice that minus 5 squared is also equal to 25, but minus 5 is less than 0. So the square root of 25 is not equal to minus 5. In other words, we define the square root to be non-negative. It has to be a positive, right? We choose the positive square root to be the square root. I think your book also calls this the principal square root. Okay, anyway. So just a algebra fact. If we take the square root of x squared, what happens? We get x, well, sometimes. We get x if x is greater than or equal to 0, but we get minus x if x is less than 0. Well, I wouldn't. It's a variable. So it depends on, So, for example, the square root of minus 2 squared is equal to minus a minus 2. It's equal to 2. Whereas the square root of 2 squared is just equal to 2. Square root has to be, by definition, positive or 0. That's the definition. Now this has another name. This is the absolute value of minus 2 is 2. The absolute value of 2 is 2, right? So it's not an accident that that also does the same pattern, because in fact the square root of x squared is a formula for the absolute value of x. All right. I think I talked about these things at least a little bit back when we were solving the absolute value equation earlier in the course. Yeah? Remember that? And then we looked at the absolute value inequalities. Okay, anyway, we move on here. Work some problems. I need to give you another definition, actually. Definition. The cube root, all right, of y is equal to x is true if and only if y is equal to x cubed. So, for example, like the cube root of 8 is equal to 2, since 8 is equal to 2 cubed, right? I missed my 3 there. That's kind of important. So, and the other nice thing about cube root is if I could look at the cube root of like minus 2 cubed, what is it? It's minus 2. Since what? Since minus 2 cubed, right, is minus 8, right? And that's equal to, well, there it is. See this? The cube root of minus 8. So what I'm telling you is it is true that the cube root of x cubed, guess what? It's equal to x. So the cube root is different than the square root. Like the square root, you got to worry. The square root of x squared, sometimes it's x, sometimes it's minus x. But the cube root of x cubed, it's just x again. So we can take the cube root of a negative number. That's okay. All right, anyway, let me move on here. Where are the problems in here? And I guess I should bump it up a notch here. Similarly, here's the definition. The nth root of y equals to x if and only if y is equal to x to the n. So this is the nth root. Nth root. And here's the story. If you take the nth root of a to the n, what do you get? You get the absolute value of a if n is even, right? And you get a if n is odd. So this is how the nth root of a to the n simplifies. It depends on whether you're looking at an even or an odd root. What we already saw happen with 2 and 3 continues to happen for higher numbers. All right, so what are the properties of let's see here. So some properties that I often use. If we have the square root of a times the square root of b, it's equal to the square root of ab. This is also true for nth roots. All right, the nth root of a over the nth root of b is the nth root of a over b. All right. Let's see here. What else can I tell you? And here, I'm assuming a and b are positive just to keep things simple. So if x is greater than 0, and you have like x times the square root of a, then we can rewrite the square root of, you can rewrite x as what? If x is greater than 0, it's equal to the absolute value of x, right? Which is equal to the square root of x squared, right? So what I'm saying is if x is positive, you can bring it inside a square root, but when you do, what happens? You get an x squared. So if we bring in x from outside to inside, it becomes x squared. All right? Provided it's positive. What if it's negative? How do you bring it inside? It's a little bit trickier, but if x is less than 0, then x squared of a is equal to minus the absolute value of x. See, because x is equal to minus x, so in the case that x is less than 0, the absolute value of x multiplied by minus 1 gives me x. And so then, rinse and repeat, same thing, minus the square root of x squared square root of a, which is minus the square root of x squared a. This calculation I just did is pretty tricky. That's probably not part of your course, honestly. I'm scared to ask calculus students this, honestly. Why am I showing you? For your learning. And someone looked interested. I won't rat them out. All right. Example. Where was he? I'm trying to remember what example we were on. Was it example 8? I'll call it 8. I can't remember. I'm not sure we had a 7, but here, 9 square root of y squared plus 16. You guys tell me, what's the radicand here? Right, this y squared plus 16 is radicand. Very good. The other thing I should tell you guys about is if we had so f of x equals to the square root of x, right? What would the domain be? What's the domain? All real numbers? Well, what would be the square root of, minus 100? 25. I hear 10. So if this is equal to y, then that means that y squared is equal to minus 100. Can you find a real number that squares to give minus 100? You cannot, right? I mean, if you want me to, you'd need y is equal to 10 times I, right? Like I is the square root of minus 1. Is that a real number? It is not, right? So this is not allowed. So this thing, the domain, is 0 to infinity. We can only take the square root of a positive or a positive number is 0. What's the square root of 0? 0. Very good. So in this vein, you guys tell me, what's the domain of the function? What's the domain of the function? We had f of x equals the square root of 3x minus 2. What's the domain? In interval notation. Can you guys figure that out? No? So what we need is we need the input, the radicand, to be non-negative. We need 3x minus 2 to be greater than or equal to 0. So this should give you a certain sense of nostalgia for like week 2 in the course, right? And this is 3x greater than or equal to 2, right? Which, of course, divide by 3, I get x greater than or equal to 2/3, which tells me that the domain of f of x here is 2/3 all the way out to infinity. Okay. So let's look at some simplification problems, yeah? So these are from section 6.1, like 43 to 50, somewhere in there. So here we have the square root of 16x squared. Example 11, the square root of minus 12 times c, quantity squared. Example 12, the square root of x squared minus 4x plus 4. All right. And I'll put up a few cubes here. Example 13. Let's look at the cube root of minus 64x cubed. Example 14, the cube root of 0.343 times x plus 1 cubed. Need a charger? Yeah. It's Android, iPhone? Yeah, sorry. You could have guessed I was an Android user? I take that as high praise. Thank you. No, I became aware of the fact that I'm all alone here in that when I needed to find a charger for my phone yesterday. It's like, no one has USB-C here. No one. I actually had to go over to the Dollar General and buy one. Sad but true. But they had it. It was not $1 though, I'll tell you that. Okay, so here we go. This is the square root of 16 times the square root of x squared. Square root of 16 is 4. Square root of x squared is the absolute value of x. There you go. Next, this is the absolute value of minus 12c. What are the properties of absolute value? Do you guys remember? Like absolute value of AB is absolute value of A times absolute value of B. That's a property of absolute value, right? So this is absolute value of minus 12 times absolute value of C, which you already were telling me was 12 times absolute value of C, right? Very good. Got it? Can we factor this one? You're like, factoring again. Yes, it's always factoring. This is x minus 2 quantity squared. So we have the square root of something squared. This is absolute value. Absolute value of x minus 2. So there you go. Another one bites the dust. What is the cube root of point, example 12. So cube root, the cube root of a product is the product of the cube roots. So I can break this up. This is really like the cube root of minus 64 times the cube root of x cubed, right? So 64, right, is 4 cubed, by the way. It's 16 times 4, which is 16 times 16, 4 times 4 times 4. 4 cubed is 64. So minus 4 cubed is minus 64. So what this is minus 4. And the cube root of x cubed is just x. So when it's an odd root, we don't have to do the absolute value. We just get x back again. 343, that number is vaguely familiar. What is that? Hey, but you can use a calculator. That's the thing. So one of the things you might want to figure out is like where the cube root thing is on your calculator. So for me, there's actually a cube root button. You can also just take the 1/3 power. We'll talk more about that. But let's see here. So third root of 0.343, what do I get? 7/10. So Okay, so 7/10 cubed is 343 over 1,000, which is 0.343 for what it's worth. Anyway, this gives me 7/10. And what's the cube root of x plus 1 cubed? It's an odd root of an odd power, so we just get back what's inside. In other words, the cube root and the cube, they're inverse operations. So we just get this. Question, what if instead of this I had like a slightly different thing? What if I have like the fourth root of, I don't know, 81 times x plus 2 to the fourth power? How's that simplify? What's the fourth root of 81? You could use your calculator, but I would just point out to you that 81 is 9 times 9, which is 3 times 3 times 3 times 3. 81 is 3 to the fourth. And so the fourth root of 81 is 3. But how does the fourth root of x plus 2 to the fourth power simplify? 3 times what? Is it x plus 2? No, this is an even power, so we have to do absolute value. So it's absolute value of x plus 2. All right, I've probably done too much in that section. Let us look at the next section. So this is all radical notation, exponential notation. What's exponential notation? Instead of writing the nth root of a, we write a to the 1 over n. A to the 1 over n is the exponential notation. So for example, square root of a is a to the 1/2 power. Cube root of a to the 1/3 power. You guys, I gotta stop talking. I barely hear the voices in my head at the moment. It's okay. But, see, here we go. So there are properties that I should write for you. Properties. If we have ab raised to the s power, we get a to the s times b to the s. So this is one property of the exponents that's important to know. Another one is if we have a to the s raised to the t power, we get a to the st. Right? Another one that we have to use sometimes is like 1 over a to the s is a to the minus s. All right? So with those in mind, let's see if we can do some of these problems here. We're asked to rewrite with positive exponents. Rewrite with positive exponents. So here's one.